Good evening, class. We are looking at practice test number 4, module 4, covering chapter 7 and 8. And here's chapter 8, analytic geometry. First, we have a pledge. As always, before we start the exam, we want to have a pledge that we just do the exam on our own, and that's it. The parabola, what is the definition? A parabola is the set of points in a plane that are the same distance from a fixed point called the focus, and from a fixed line called the directrix. As a result, a parabola is the set of points P for which distance between F and P, F is a focus. If you pick a point, the distance from that point with coordinates x, comma, y to the focus, and the distance from that to a directrix, if you drop a perpendicular, they are the same. That is the definition. So in any format that you have it, you have a directrix which is perpendicular to the axis of symmetry. You have a focus that goes through the axis of symmetry at some point. The vertex and the axis of and focus are both on the axis of symmetry. And again, axis of symmetry is perpendicular to the directrix. In all of this, you pick a point, connect it to focus, and drop a perpendicular to the directrix. As you can see, this distance and this distance must be the same. We are looking at this distance and this distance. Focal distance. The focal distance of a parabola refers to the distance from the vertex, the point where the x-axis, the axis of symmetry intersects the curve, to the focus along the axis of symmetry. This distance is the same from the vertex to the directrix. This distance is referred to as either P or A. Okay, so let me show you. This one is P or A. And just go back. So as far as the concept of a focal distance is concerned, this distance, which is equal to this distance, which is equal to this distance, is known as a focal distance. Because in algebra we used A as the leading coefficient, I rather go with P, okay? And so when we learn that this distance is P, as long as we have the location of the vertex, we can locate the focus at A0, for example, to the right of it. And because it has the same distance and it's a vertical line, x equals minus A or minus P. Parabolas have many applications in electricity, mechanics, and optics. The vertex is located at HK. This one opens up. This one opens down. And X equals H. is the axis of symmetry when it opens up or down. Recall equation of a parabola. This is what we have learned from before. Y equals a times x minus h quantity squared plus k. This is a vertex format at h and k. The parabola opens up if a is positive and down if it's negative. Axis of symmetry, x equals h. Y equals ax squared plus bx plus c, or a times x minus h quantity squared plus k. Sometimes they call this one standard form, sometimes this one. I like to call this one the vertex format. The vertex has the x coordinate when it opens up or down, h equals minus b over 2a, and you can plug in and find the y coordinate k of the vertex. Equation of a parabola opening sideways, left or right. X equals a times y minus k quantity squared plus a, the vertex still at h and k. The parabola opens to the right if a is positive and to the left if a is negative. Axis of symmetry this time is y equals k. So x equals h when it opens up or down. Y equals k when it opens sideways to the right or left. In this case, to the right a is positive. In this case, to the left a is negative. And we can say x equals ay squared plus by plus c. Now, notice, in this case, when it opens up and down, it is quadratic with respect to x. When it opens sideways, it's quadratic with respect to y. When it opens up and down, a times x minus h quantity squared plus k. When it opens sideways, a times y minus k quantity squared plus h. So vertex, k equals minus b over 2. All right, let's continue with that. Equation of a parabola, vertex at 0, 0, focus at A0 or P0. And directrix, x equals minus a, y squared equals 4ax or 4px, depending upon whether you use a or p. In many texts, they use a. I'd rather go with p because of what we just looked at, y equals ax squared plus bx plus y, and so on. Okay. Now, if it opens sideways, you start with the vertex and you realize that the focus is inside the parabola and the directrix is outside. And this distance is identical to this distance, which we call it the focal distance. And you can easily figure out the coordinates for this one and the equation for this. This one, focus is at minus a0 and directrix x equals a, y squared equals minus 4x or minus 4px. Again, as far as the location of a focus and the equation for directrix is concerned, I will show you in a moment. I will draw first and then I'll figure it out. The vertex is at 0, 0, x equals a y squared. It opens sideways, so it's quadratic with respect to y. When a is positive, opens to the right. When it's negative, opens to the left. And this is what we learned in algebra. Now with this focal distance, y squared equals 4px. Or if it opens to the left, minus 4px. Opens up and down. Focus at 0a and directrix y equals minus a, x squared equals 4ay or 4py. And this one opens down. X squared is minus 4ay or minus 4py. The vertex is at 0, 0, y equals ax squared. I want you to compare these two. In general, this one, quadratic with x, opens up or down. A is positive up, negative down, and this one sideways. And I've already, a positive opens up, negative sideways, negative down. This one is sideways. X squared, this one is y squared equals 4px. This one is x squared equals 4py. when it opens up, and minus 4py if it opens down. The focal distance, as I mentioned, either P or A, not this A. I can't emphasize this enough. So how does that work? Y squared is 4px or minus 4px, x squared is by 4py or minus 4py. The relationship between a P and A, I'm talking about between this A and this P, or between this A and this P, is that P equals 1 over 4A or A equals 1 over 4P. In other words, you can go with what you have already learned and then go to the to find the information about focal distance and otherwise. We mainly need it for something like lattice rectum and so forth. Okay, so what is that? Again, just as an example, this one has vertex at 0, 0, focus at P0, remember it's inside, and therefore D equals X equals minus P. I'm going with P, okay? And any point, for example, this point having coordinates X, comma, Y, you drop it perpendicular to the directrix and you connect it to focus, these two distances must be the same. This distance, use, okay, this distance is the P, everybody. The same as this distance. Okay. All right. What is the lattice rectum? If you start from the focus and draw a line parallel to the directrix, it cuts the parabola at 2 points. Those 2 points, the distance from those 2 points from here to here, this distance, this is called the lattice rectum. You can calculate the distance. And so here's what's happening. The lattice rectum of a conic section is the chord, the line segment, through a focus parallel to the conic section directrix, and the value, this distance from here to here, is 4 times P. The length of the parabola's lattice rectum is equal to 4 times the focal length, 4P. I can quickly show you why. Its end points lie on the curve, okay? As you can see, for example, here. By the way, you see the focus at 2, 0. So this has the same X coordinates. Do you follow what I'm saying? And then this distance is 4P, this distance is 2P, so you go up by 2P. Look at this parabola. Look at the focus. Look at the vertex, okay? And this distance, everybody, equal this distance, or this distance equal to this distance is equal to P. Focal distance, by definition, is this distance, which is the same as this. So what do we have? Recall, by definition, the distance D from the focus to any point P on the parabola is equal to directrix from P to the directrix. So from this point, the vertex to the focus is the same as this distance to the directrix. These two must be identical by definition. And each one is P. That is called the focal distance. Therefore, this is P, and from here to here is 2P. This is 2P, so is this one. So this entire thing is 4P. Believe it or not, that's the proof. All right, let's look at an example to make some sense out of this. Recall from algebra, given the function f of x equals x squared minus 6x plus 8, x is the same as x minus 3 quantity squared minus 1. Determine which way the graph opens, find the vertex, accept symmetry, draw the graph, find the domain and range, and also. So I wanted to do what we did in intermediate algebra, and then we'll move on to new stuff here. So first and foremost, A is 1, it opens up the vertex. This is a vertex format. Otherwise, so it's located at 3 minus 1. I want you to see that. Otherwise, class, from here, you can say x equals minus b over 2a, which is minus negative 6, 2 times 1, and it's equal to 3. You can go that one route if you, okay. So that means the axis of symmetry x equals 3. Let me erase my work. This is the y-intercept 0, 8. Set x equal to 0. It's easier to get from here. Um, 0, 8. To find the x-intercept, set y or f of x equal to 0. It's easier to set this one equal to 0. And you're going to factor, you want two numbers. The product is 8. The sum is negative 6. And so x is either 2 or 4. That means 2 comma 0, 4 comma 0. Here's the table. Let me explain a couple of things about the table. We have 2, 0, 4, 0. We have 3 minus 1. We have 0, 8. I'm going to discuss that one in a moment. For now, I want you to ignore that. These are the points we've already got. The y-intercept, the x-intercept, the x-intercept, the vertex. So we're going to graph this, and we are going to put the vertex at 3 comma negative 1. We're going to put the y-intercept at 0, 8. We're going to put the two x-intercepts. And now the axis of symmetry x equals 3. So according to the axis of symmetry, if this distance is whatever it is, we go the same distance, there is a point with the same y coordinate. And because this is 3, we go 3 on this side. And that's why we get 6, 8. This one is 0, 8, everybody. This one is 0, 8. And we get this point. 6, 8. I just wanted to show you the effect of this symmetry. And so the graph looks like. Now, what about the domain? Because whenever it opens up or down, the domain is all real numbers. Whenever it opens up or down, as far as the range, the limitation comes from the vertex. Because it opens up from the y coordinate to infinity, if it opens down from negative infinity to y coordinate, in this case from negative infinity, negative 1 to infinity. This is what we have done in algebra. What I want to do, I want to add the location of a focus, and I want to add the line called the directrix. And I don't know what the answer is yet, but I should know, and I'm going to show you somewhere here is the location of a focus, and here's the line. Again, we have to figure out what they are. My point is, we know the focus is inside and the directrix is outside. Because it opens up, the directrix must be a horizontal line because it's perpendicular to the axis of symmetry. So what about this distance? We know this distance. We know this distance is equal to this distance, and it's equal to P, focal distance. And we're going to find that. And furthermore, we know the relationship between the focal distance and A. Remember, A is 1, and P is 1 over 4A. So all of that to help us with more information. And remember, this was done as far as algebra is concerned, but we're going to continue with that. So this is the information from the previous page. Okay. So P equals 1 over 4A. And again, A is 1, so that's equal to 1 over 4. As I mentioned, the focus is somewhere here. Okay. So we know the vertex is located at 3, negative 1. So somewhere here is the F, and that has the same X coordinate. So again, that's why you don't have to memorize the way they had it there. Okay. Just I know that all I have to do, the y coordinate of the vertex go up by 1/4. So -1 is the y coordinate, go up by 1/4 by p, and this is the focus. This point, let me erase my work. And now, as I mentioned, the directrix is somewhere here, and this distance also is p, right? So that means whatever the y coordinate of this point is, right? This was 3 comma -1. We're going to come down by p, and y equals that is the equation of a directrix. So y equals -1 minus p. That means -1 minus 5/4. Again, I erase my work. I just wanted to just make a point. This is how you find that, okay? And so that's it. We want to go with the equation in this format also. Remember that we have this equation. This is the format we learned in previous courses. Also, this is the format here, reminding you, we said x squared equals 4py, or x minus h squared is 4p times y minus k. And remember, over here, we have 1, 4 times p. All right. Now, latus rectum. This distance is latus rectum. We want to find the distance is very simple. Okay, we said it's 4p from here to here. We want to find the end points. Now, if I want to find those end points, okay, I'm interested in the x and y. Again, this focus, we can find it, and then we use that to get to those two end points as well. Okay, so the focus, let me just use a different color here. We can find it, we've already found that, at 3, -3/4. Okay, so this point as well as this point must have the same y coordinate. So I can put the y coordinate here and find the x. That's one way to do it. There are two different ways, and I'm going to quickly discuss both of them. So y equals -3/4, because this point, and this point, they all have the same y coordinate. What points are we referring to? The focus and the two end points that cut the graph, they must have the same y coordinates. We already have the y coordinates for the focus, then we have the y coordinates for these 2 points as well. What are the x coordinates? We don't know. So we can use the y coordinates here and find the x. And I hope you see that you can say x minus 3 quantity squared, y is negative 3/4 and 1 is 1/4, which makes x minus 3 plus minus 1/2, and x is 5/2 and 7/2, and those are the pairs. Okay. However, and this is fine. Then I'm going to show you a different method. LR, left and right method. This is the second method. You choose the one that is easier for you. We already have the focus at 3 comma negative 3/4. We have the focus. So we can go to the right and left to figure it out, which means we have the same y coordinate. And we're going to add plus minus 2p. So y is fixed at negative 3/4 for this point, this point, this point. Add 2p and subtract 2p. So plus minus 2p. Okay, and remember, this is p. 2 of that is 1/2 to the x coordinate. So 3 minus 1/2, 3 plus 1/2, and we get exactly what we have here. So one method, put the y coordinate of your focus in here, find the x coordinates. The second method, focus, go to the right and left by 2 times p. Which one is easier? You decide. As long as you can do one of them, you're in good shape. So those are the 2 pairs, okay? With coordinates 5/2 and negative 3/4, 7/2 and negative 3/4. All right, identify the coordinates of the vertex, the focus, the length of the lattice rectum, and the equation of the axis of symmetry, and the directrix. Graph the parabola y minus 2 squared equals 4/5x plus 4. And we have various equations here. You can always put it back in the same format we've had, okay? But I hope you see that this means x is negative 4, y equals 2. Though that's the um, vertex, and y has exponent 2, so it opens sideways, and this is positive, opens to the right. So minus 4, okay, 4 to the left, 2 up. Now, because it opens sideways, now y equals 2 is the axis of symmetry. Now, what I want to make a point of before we continue, this is the location of a vertex. I want you to know the graph looks something like this already. Somewhere inside is the focus, and this line is the directrix. That's a vertical line. And this distance is P. Okay, so all of that will help you find everything. So all you have to look for is the value of P. So you don't have to really work hard. Again, you already have a general shape. This is not to scale, of course. But again, I'm going to repeat because I want to make sure we understand that. So the graph opens to the right. This is the vertex, and it goes through the vertex. Now, the focus, this distance is P, so we have to find P. And that gives us the location of the focus. And this distance is also P. That gives us the equation of the vertical directrix. Okay, so remember what this one is. This one is 4P or A. Take a look at this one. So 4p is 4 over 5, p is 1 over 5 or 0.2. The vertex is located at minus 4, 2. The x coordinate is minus 4. The y coordinate is 2. So this point has the same y coordinate. What about the x coordinate? Minus 4 plus p. Minus 4 plus p is minus 3.8. Of course, this is way off, and I did it on purpose. So I just wanted to make sure that everybody can see that it's somewhere inside. So it's way off, right? And so is my directrix. But the idea is that how do you find the equation of a directrix? It's a vertical line, x equals some number. What is the x equals some number? Again, go back to the vertex. X has coordinate negative 4. So you go to the left of it by p. So minus 4 minus p is minus 4.2. And this is the line. Again, now I'm going to erase my work. And that's the graph. So again, I just want you to know how the graph opens. Inside is the location of a focus. Outside, the line perpendicular to the axis of symmetry is the directrix. Now, if we draw a line segment parallel to this guy, this is called the lattice rect. Okay, and the distance from here to here is 4 times p. So the lattice rectum of a conic section is the chord through focus parallel to the conic section directrix, 4p, 4 over 5, or 0.8. Just, the information I wanted to, you see that. Now, what are the end points? Well, there are two ways. This is the coordinates of the focus. So you're going to go up, okay, and you're going to go down. You have two choices. You can say x is negative 3.8. Let's put that into this equation and find the y, as we did last time. So x is negative 3.8, and 4 is 0.2 times 4 over 5, 0.8 over 5, and then do the math. Or remember the left and right method. Now we're going to go up and down. Okay, up and down. So from here, we are going to go up and down. Look at the so look at the y coordinate as at 2. Look at the p as 0.2, and this is 2 times this distance, everybody. And let me use it. Okay. This distance is 2p, so is this distance 2p. So to find those pairs, this one and this one, okay, we have the same x coordinate. Now add 2 times this and subtract from it. So 2 times 0.2 is 0.4. Okay, subtract it from 2 and add it to 2. LR method, left and right method. In this case, I should say up and down. Given that the focus is at negative 3.8 comma 2, x is negative 3.8. Add plus minus 2p, that means plus minus 2 times 0.2 plus minus 0.4. To its y coordinates, we get negative 3.8, 2.4, and negative 3.8, 1.6. So that's this one and this one. Very straightforward. I hope everybody is okay with that class. Use the graph of the parabola to determine its equation in standard form. This is given. So the parabola opens down. So we can say x squared equals 4py, or x minus h squared equals minus 4py minus k. That's the equation. Or you can even go with y equals a times x minus h quantity squared plus k. I'm going to discuss both methods quickly. So you don't even have to go this route. So the very first thing you have to notice the location of these two, the vertex and the focus. Negative 3, 5, negative 3, 319 over 64. This distance is p, everybody. So vertex, focus, those are given. And p is this distance. So if p is this distance, the difference between these two, which is 1 over 64. So this distance is 1 over 64. So x plus 3, location of the vertex, x plus 3 quantity squared, minus 4 times the p, 1 over 64, y minus 5. And of course, the product of these two numbers is negative 1 over 16. And you're done if you want to go that route. Minus 1 over 16, y minus 5, and you're done. If we want to go with y equals a times x minus h quantity squared plus k, the vertex at negative 3, 5. So we're going to write a times x minus minus 3. That means plus 3 squared plus 5. So that's the first. And a is 1 over negative 4p because it opens down. And p, we found it to be 1 over 64. So minus 16, replace the a, and that's what you have now. Notice from here, everybody, to go here, okay? If you take this to the other side, that means multiply both sides by negative 16. And then move the negative 5, that means add 5. So I hope you see they are the same. So it is your choice. If it's easier for you to go this route, just work this way and then put it in this format if they are asking. Either way makes no difference. Given the function, express it in standard form. Now, again, like I said, I like to call this a vertex format. F of x equals a times x minus h quantity squared plus k, and find the x-intercept, the y-intercept, the vertex, find the axis of symmetry, and graph the function. This is what we have been doing, everybody, okay? In algebra. So that's what they want. They don't want anything else. And so this is the function. You don't have to put it in this format, but since they asked, we are going to do that. I hope everybody's clear, because if I want to find the vertex, for example, x equals minus b over 2a and plug in, okay? So there's no need for that. However, if we want to go to put it in this format, that means we have to put these two together. That means we're going to take the 2 out, 2 times x squared plus 2x, and then we have the 6. Now we're going to complete the square here. To complete the square here, b is 2, half of it is 1, square it is 1. So we are going to add 1 to this. If I add 1 to this 2 means I'm really adding 2. So I either have to add 2 to the left side or subtract from the right side. In other words, I'm adding 2 times 1, so I'm subtracting -2 from the same side. That's the best course of action. So we get 2 times x plus 1 quantity squared plus 4, which means the vertex at negative 1, 4. So if the vertex is at negative, let me erase my word. Negative 1, so it's negative 2, negative 1, and then 4, it's there somewhere. A is 2, it opens up. And look at the vertex. If we have the vertex here and it opens up, we can't have any x-intercepts. However, to prove that, you can calculate b squared minus 4ac here. B squared is 4 squared minus 4 ac minus 4 times 2 times 6. Negative 32, that means this doesn't have any roots, any zeros. That's the meaning of it. So the y-intercept is located at 0, 6. 0, 6 from here. And the axis of symmetry x equals negative 1. And then using the axis of symmetry, we must have a point here, negative 2, 6, because this distance is 1. We go the same distance. We end up with negative 2 with the same y-axis. And that's the graph. And believe it or not, this is it. By the way, as far as the x-intercept is concerned, you can set this equal to 0 and you see that it doesn't have any just in case. Identify the graph of each equation, 10x squared plus 10y squared minus 100 equal to 0. Okay. This one is a circle. Why is that? Remember, circles are in the form of x squared plus y squared equals r squared. If you're talking about center, that's 0, 0. Ellipses are in the form of x squared over a squared plus y squared over b squared equals 1. Circle is a special case of ellipse where a and b are equal and we call them r. Hyperbolas are x squared over a squared minus y squared over b squared equals 1. Therefore, it's easy to see this is a circle because both x squared and y squared are there. We have both of them must be there with equal coefficients. This coefficient is 10, this coefficient is 10. As long as they are identical, are on the same side of the equation, that's a circle. Of course, you can prove it by putting it in standard form, but there's no need for that. In a split second, you can say it with this justification. What about this one? This is an ellipse. Why is that? Now, both of them exist, x squared and y squared, but they have coefficients that are different. They both have the same sign, but one is different. Okay, but they must have the same sign. Therefore, both x squared and y squared are there with different coefficients and the same sign on the same side of the equation. This one, let's bring it to the same side. It's a hyperbola by looking at it, but if you bring it to the same side, all it is, both x squared and y squared exist, but they have coefficients with different signs, and that's the key. Both x squared and y squared are there with coefficients that have different signs on the same side of the equation. If they belong to different sides, then they can, as you can hear, they can have both positive or both negative. And that means it's a hyperbola. So I hope you can recognize it just quickly by looking at it in a split second. Determine whether the graph opens up, down, left, or right, and these are the equations. So first and foremost, parabolas. There is only one quadratic variable. You have either x squared or y squared. That means if you look this one, You have x squared. This is y, okay? Okay. This one has x squared, this is y, this has y squared, this is x, and all of them are parabolas. So you have one of them, not both. In this case, it's quadratic with respect to x, so it opens up or down. A is negative, it opens down. Y equals ax squared plus bx plus c, or a times x minus h quantity squared plus k. X equals ay squared plus by plus c, or a times y minus k quantity squared plus h. So a is negative, opens down because it's x squared. Again, it's x squared, so it opens up or down. A is 1, it opens up. Because it's y squared, it opens sideways. Right or left, because a is 1, positive, it opens to the right. Very straightforward, everybody.